Hello, everyone. Today we're going to start talking about probability distributions. Let's start with some definitions. A random variable is a variable represented by x that has a single numerical value determined by chance for each outcome of the procedure. A probability distribution is a distribution that gives the probability for each value of the random variable. It is often presented in the format of a table, formula, or graph. A discrete random variable has a collection of values that is finite or countable. There may be infinite values, but there must be a way to count those values. For example, flipping a coin. And a continuous random variable has infinitely many values, and the collection of values is not countable. For example, height. Infinite many possibilities of height, so it would not be a countable variable. So let's look into more probability distribution requirements before we look too specifically at an example. One, there's a numerical random variable, and its numerical values are associated with the corresponding probabilities. The sum of the probabilities has to be 1. Almost 1 is okay. If it's 0.0001 or 0.9999, that's okay. That tends to happen when we use rounding. We have very large decimal numbers. That's okay. As long as the probability is pretty close to 1, then it's normally just a rounding area. And then lastly, the probabilities of x have to lie between 0 and 1. Can't have a negative number, so all of the numbers have to be between 0 and 1. That way it ensures they add to 1. So you need those 3 requirements. So now let's look at an example to put some ideas behind these definitions. So we have this table in the top corner. X is going to be our random variable. And we're going to let our random variable equal the number of females when 2 babies are born. And we're going to make the assumption that male and female births are equally likely. So the probability that there are 0 females is 0.25. Probability there is 1 female is 50%, or 0.5. And the probability of 2 females is 0.25. And we can check those easily with the multiplication rule. 0 females, there's a 50% chance. Twice, 50% times 50%, or 0.5 times 0.5 is 0.25. Chance of 1 is just 50%, right down the middle. And the same thing with 2, 50% times 50%. So this is going to be a random variable because either 0, 1, or 2 girls can be born. And the 3 conditions are also going to apply. X are numerical values, which is needed. The sum of the probabilities is 1, and each probability is between 0 and 1. So we have our 3 conditions met. And then we say this is a discrete random variable because there are 3 possible values, and 3 is a finite number. We can count to 3, so it's discrete. We can also look at this as a histogram as well. A probability histogram of the previous example would be the following. We take the probability, and we're going to use this really messy equation to find it. It's a little easier to do it by technology. But 1 divided by 2 times parentheses 2 minus x factorial, x factorial. I'll do one example here. I won't make you calculate this, but what this is saying is if we have 1 over 2 times 2 minus, if x is 0, factorial times 0 factorial. 2 minus 0 is 2. This is 1 over 2 times 2 factorial. 0 factorial is just 1, so that can go away. 2 factorial is 2 times 1. So this is just 1/4. A little more complicated than we'll talk about, but this formula does work. So we can take the probabilities we have here of 1/4, 1/2, and 1/4, and we can do it as a histogram as well. So instead of frequency, it's probability instead. Some formulas that we might see that have to deal with probability distribution. A lot of times we will not calculate these by hand, instead use technology. But if we were to do it by hand, we might need these formulas. If we want to find the mean for a probability distribution, we're basically going to take the variable x, multiply it by the probability, and then sum those all together. So if I did 0 times the probability of 0 girls, 1 times the probability of 1 girl, 2 times the probability of 2 girls, add those numbers together, that would give me the mean for the probability distribution. Variance, we denote as sigma squared for a probability distribution. Remember, it's just the square, the standard deviation, is the summation of x minus the mean squared times the probability. So same way we typically find variance, we take each individual random variable value, subtract it from the mean, we're going to square that number, multiply it by the probability, do that for each possible random variable, we add those numbers together, that will give us our variance. That is a lot of work. Typically, we use technology to find this number. It would be a lot of computations to do it for each random variable if we had a bunch of possible values of x. For the example we had, it wouldn't be the end of the world because there's only 3 numbers I would have to plug in, but still typically we would use technology here. I gave another formula, 5-3, another way to find variance. It's a little easier for manual calculations, but we're not going to focus too much on that. And then we know to find the standard deviation, if variance is the standard deviation squared, to find just the standard deviation, we can take the square root. Square root of squared would give me the standard deviation. So let's break this apart a little more. We have what is called expected value. The expected value of a discrete random variable x is denoted by E. And E is the mean value of the outcomes